We're going to find a line integral, and this is a line integral over a vector field. So instead of our integrand being a scalar function like we did before, now our integrand is a vector field. And so this vector field in particular, and the line that we're integrating over is going to be this half circle. We can sketch that. There's a direction to it. It has a starting and ending point, so I put the direction in there. In these integrals, the direction matters. In the scalar line integral, the direction did not, but in these integrals, the direction will matter up to a sign change. We need a vector valued function that represents this path, the half circle from 1, 0 to minus 1, 0. We know how to parameterize a circle. That's going to be cosine t, comma sine t. And we're going to have t ranging from 0 to pi. So that is our parameterization. That's our curve. So the integral, the line integral, becomes an integral from 0 to pi, the domain for the parameter t. And we just need to write our vector field f as it is along this curve. So along this curve, x is cosine of t, y is sine of t. So I have sine of t minus cosine of t, comma, x is cosine of t, dotted with the derivative of r prime. So r prime is negative sine t, comma cosine t. I've got a dt off screen, so there's a dt on there. We'll put it up here when we do the dot product. So this integral looks like 0 to pi. Remember, this here is f, and this here is r prime of t. Sorry, I trailed off the screen a little bit. It'll be clear here when we rewrite it. So we do the dot product, right? The dot product is we multiply the first components together. So that's minus sine squared of t, and then sine times cosine. We have a positive sine t cosine t. And then the y components, we have a cosine squared of t, and then there's the dt. So that is what the integral becomes. This is now a Calc 1 style integral after we've done this parameterization of the curve and the derivative of it and the dot product with the vector field. We're left with an integral in t, and this is an integral that we could do in Calc 1 or Calc 2, and that's what we do. So it turns out there's an identity that helps us here. This is 1/2 sine of 2t. And we know how to integrate sine and cosine. Cosine is 1/2 plus 1/2 cosine squared. And sine squared is 1/2 minus, so 1/2 cosine 2t. But with the minus sign, it becomes a plus 1/2 cosine 2t. Negative 1/2, positive 1/2 cancel. These can add up to just be a single cosine of 2t. And so we have this integral, which we know how to do, plugging in the endpoints. What we end up with, in this case, is 0. That didn't show up. Let me put it here. There we go. 0 is what we end up with when we do that integration. So that is a line integral over a vector field. We need the vector field. We need it in terms of the parameterization, and we need the r prime of the parameterization. Then it's a dot product and an integral.